To understand cells, you really need to understand their world, which brings us to my favorite show, Atoms and Molecules. Imagine you have a piece of chalk and you break it in half. Both of those halves are still chalk. But what happens if you keep on breaking it and breaking it tinier and tinier, even when you can no longer see it with your eye? You get to a certain point where you cannot break it any longer without changing it into something else. The smallest point that you get to before you change it is called the atom. And the subatomic parts, the parts that make the atom, is what form it into different atoms. For example, some atoms that you heard of, like oxygen and carbon, are going to have a different combination of these parts, as well as things like copper and gold. Elements is when the same atom comes together. For example, in gold, it's going to largely be of the same gold atoms, as opposed to compounds, which are different atoms combining together, and they're going to combine differently. Think about it this way. There are only a certain number of letters in the alphabet, yet these letters can be combined into different words. In our example, letters are like atoms, and when they combine into words, and those words can then combine into sentences and even paragraphs. And that is how atoms build everything around us. Salt is when the atom sodium gives some of its electrons, which are subatomic parts, to chloride. And when one atom takes electrons from another atom, it's called an ion. Water has a different type of bond called covalent, which means that the different atoms in water are going to share the electrons. When atoms lose electrons, it gives it a positive charge, and when they gain electrons, it gives it a negative charge. Think about it like a magnet with a positive and negative end, which will attract other atoms. Now we know that water is H2O, meaning that it is hydrogen atoms and oxygen atoms in a covalent bond. With this in mind, we can now begin to understand some of the things that we know that happen to water because of these bonds.
How come some insects are able to walk on the surface of a pond, but you quickly sink to the bottom when you try to walk on water? And why do lakes freeze from the top down in winter? In a word, the answer to all of these questions is polarity. Water is a simple molecule made up of one oxygen atom and two hydrogen atoms, but it is essential to life. In fact, water makes up approximately 60% of the adult human being's body weight. The polarity within those water molecules gives this common substance the properties that make it unique and life-sustaining. Polarity refers to the unequal sharing of electrons within a molecule. For water, the bonding between the oxygen atom and two hydrogen atoms within a single water molecule is like a tug of war between a big, strong football player and a cute little toddler. Oxygen is a larger atom with more protons in its nucleus than hydrogen. These positive charges are like a person's physical strength. They are able to attract the negatively charged electrons in the bond, just like a strong individual is able to overpower a weaker individual in a tug of war. So, oxygen is able to attract more than its fair share of electrons. Because hydrogen is smaller and has less strength, or fewer protons, it loses the tug of war and attracts fewer than its fair share of electrons. So the oxygen in water behaves as though it's negative, and the hydrogens behave as though they're positive. The bonds within a single water molecule are called polar covalent bonds. Covalent means that the electrons are shared, but, as we just learned, polar means that these electrons are not shared equally. In water, the oxygen acts negative, and the hydrogens act positive. Since negative and positive attract, that oxygen is attracted to the hydrogen atoms in neighboring water molecules. A special type of bond forms between water molecules, known as a hydrogen bond. Hydrogen bonds don't just happen in water either. They can form between a water molecule and different substances that are polar or ionic. Water's ability to stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion. Now, think back to the initial questions. First, Why are some insects able to walk on water? Surface tension due to hydrogen bonding creates a thin film on the surface of water that gives enough resistance for super light insects to walk on. You can't walk on it because the hydrogen bonds aren't strong enough to hold you up. Why does ice float on top of liquid water? For most other substances, the solid state is more dense than the liquid state. But that is not the case for water. Hydrogen bonds keep water molecules farther apart in frozen water than in liquid water. The farther apart the molecules are, the less dense that solid is. So ice is about 9% less dense than water, which means it floats on the top. That's why lakes freeze from the top down and aquatic life is able to survive through a cold winter every year. It is the polarity of the water molecule and the resulting hydrogen bonding that account for water's unique properties. So, the reason that water is so special, from inside your cells to the world's oceans, is simply because it is a polar molecule.
Throughout this video, there are pop-ups which point out concepts that are going to have questions down below, which you should answer correctly and submit. If you have any questions on the concepts in this video, leave that question in the private message in the Google Classroom. And I'll see you in the next one.